When the web first began, layout was simple. You put everything into a grid of tables and called it a day. The only problem is you'd end up with tables, nested in tables, nested in tables, nested in more tables. It was a nightmare to code and an even bigger nightmare to make layout changes because everything was done in line. That's when CSS came into the picture, and suddenly we were miraculously able to separate our content from its styling by handling all of our layout with CSS. Now this made life better in a lot of ways, but also gave us a number of new concepts and layout tactics to learn. Fear not, today we'll cover them all. We'll talk about the box model, inline versus block level elements, positioning static, relative, absolute, and fixed, using floats to create multi-column layouts, and fixed versus fluid layout. We'll start by mastering the lowest level elements of the page and work our way out. That means beginning with the famed box model. The box model explains how padding, border, and margin all add to an element's appearance. Any element can have padding, border, or margin applied, so the box model really applies to every HTML element. Think about the box model a little bit like your body. The content, whether it's text, an image, or media like an audio or video file, is your guts. It's your organs and your muscles and your skeleton. It's all the essential stuff that you can't really be a human being without. Padding is like fat. You could have none or quite a bit. Borders are kind of like clothes. Sometimes you're naked, sometimes you're wearing a weird drink-through bodysuit, and sometimes you're decked out for whale hunting. That takes care of everything visible. The last bit, margin, is like personal space. It's the invisible force field of distance you need between you and everyone else to stay sane. So there it is. Content, padding, border, margin. Let's say I needed to fit an object into 250 pixels of horizontal space, but I wanted it to have a padding of 10 pixels, a border of 3 pixels, and a margin of 15 pixels. What would I set its width to be? If you answered 250 pixels, you'd be wrong. Dead wrong. Padding, border, and margin all contribute to an object's final width. So, with a padding of 10 pixels on both the left and the right, that's 20 pixels of our 250 right there. 3 pixels of border on both the left and right, that's another 6, and we're up to 26 pixels total. Margin, 15 times 2 is 30 pixels, so all told, before we've ever set the width of our element, we've already got 56 pixels of our width taken up by padding, border, and margin. So subtract 56 from 250, and you've got 194 pixels left. That's what we'll need to set the width of our element to make the total space it takes up 250 pixels. Now that we've got an understanding of the box model, we should understand the difference between inline elements and block level elements. Links, images, and spans are examples of elements that default to being inline. Inline elements are sort of like the polite elements on the bus. They only take up as much space as they need and are perfectly happy to let other elements sit right next to them. You can try specifying a width or height value in your CSS for inline elements, but it just won't do anything. Likewise, top and bottom values for margin will be ignored. Border and padding will be observed graphically, but they won't have any effect on your layout. In order to make full use of the box model, your elements will have to be block level elements. These are sort of the bullies on the bus. They insist on taking up a whole bench to themselves and won't let other elements sit next to them. Headings, paragraphs, and divs are examples of elements that default to block display. But just because elements default to one or the other doesn't mean we have to settle. You can change any HTML element to inline or block display just by setting its display property to, wait for it, inline or block. So, now we know how to make our elements inline or block, what that means, as well as how padding, border, and margin all affect the space those elements take up. So let's move it up a level. When it comes to arranging elements on a page, there's essentially two strategies: positioning and floating. Let's start with positioning. Typically you use positioning to offset an element without disturbing or reflowing the content around it. The position property in CSS has 4 potential values: static, relative, absolute, and fixed. Let's dive in with some examples. I've got 3 paragraphs here inside of a div. I've colored the backgrounds so you can clearly see what's going on. If I set the position property of each element to static, then they will take their default positions as you see here. Static is the default. But if I change the value of the second paragraph to relative and specify a top position and left position value of 5 pixels, let's see what happens then. Boom! It's 5 pixels down from the top and 5 pixels right from the left side. If I change the top and left to bottom and right, we see that it's 5 pixels up from the bottom and 5 pixels left from the right-hand side. Notice how it hasn't pushed any of our other content out of its way. Relative positioning shifts an element relative to its default position without affecting the other content around it. Now let's look at absolute positioning. Let's take that second paragraph and switch the position property from relative to absolute. Refresh, and we see that the second paragraph is now 5 pixels up from the bottom of the browser window and 5 pixels left from the right side of the browser window. But notice also that the space between the first and the third paragraph has collapsed. Absolutely positioning an element actually removes it from the flow of the document, and the surrounding content reflows to pretend like it was never there. Now pay special attention here. There's a subtle trick you should know about when using position absolute. The absolutely positioned element will position itself based on the first parent element that has position relative applied. So, if none of its parent elements have position relative applied, then it positions itself absolutely to the browser window. So let's actually add this to its parent element and check it. There it is. 5 pixels up from the bottom of the parent container and 5 pixels left from the right-hand side. Now you'll probably use this trick a lot. For example, it's great for side notes in a larger body of text. Check out the articles on strangenative.com to see a few examples of this in use. Just as with absolute positioning, fixed positioning removes an object from the flow of the document and places it relative to the browser window. Now there's no tricks here, but the difference between absolute and fixed position is that fixed position always fixes an element to the browser window. So as you scroll down the page, it actually won't scroll with the content, but remains fixed on the screen exactly where you told it to be. This is great for things like site navigation or controls that you always want to be visible on the page, regardless of how far the user scrolls down. Using the position property is awesome when you want to rearrange elements without disturbing their neighbors. But what you'll probably want to use more commonly is floating. The float property can have 3 values, left, right, or none. Setting float left shifts the element to, you guessed it, the left, and reflows all the neighboring content around it. Float right does the same, but moves the object to the right. Float none just sort of puts the objects into their default flow. Here's a really simple use case. Let's try and flow some text around this image. I'll add float left and width 50% to the image in my CSS. That's all it takes to make the image half the width of its container, shift it to the left, and then flow the text neatly around it. Let's change it from left to right. It shifts to the right, and all of our text still flows around it. Floating also provides us a way to create full multi-column website layouts. Don't believe me? Well, let's take those 3 paragraphs again and float them all left with a width of 33.3333%. There we go. We get 3 columns of content. Not convinced this is useful? I'll just tweak a couple things here and blammo. Doesn't this look a lot like the websites you see out there? Paragraph 1 has no float applied to it, which makes it stretch across the top as sort of our website header. Paragraph 2 is like our little left sidebar. It's floated left with a 20% width and a height of 500 pixels. And then paragraph 3 is like our main content column at 80% width with a height of 500 pixels to match the sidebar. Now, pay attention here. Have you noticed anything odd yet? Look around, wait for it. There it is. The gray parent div that should be wrapped around all these paragraphs in the HTML appears to have collapsed. Now when child elements inside a parent element are floated, the parent will collapse like a house of cards, unless you do what's called clearing the float. There's 3 basic ways to clear a float, and surprisingly, they're all pretty janky. The first is that you can add an empty div with a CSS rule of clear both. This is an awkward option because you're adding content to your HTML purely intended to control style. It's practical, but philosophically a no-no. The second option is to set the parent's overflow property to hidden or auto. Now be careful with this one because if you set a width or height on your parent element, you could inadvertently chop off content or end up with unwanted scroll bars if the content is taller or wider than the height or the width you set. Yuck. Now the third and last option is to use the after pseudo class. This one is super crafty and I like it. Create a CSS rule with the parent element :after and give it the following properties. This will insert some content with a property of clear both, but from your CSS, thus clearing your floats and restoring the integrity of your parent element without compromising your philosophical standards. So check out the links below if you're an Uber nerd and want to learn more about the power of floating and some of the issues involved in the whole clearing debacle. So let's take it one more notch up. You're well on your way to being a layout dynamo, but there's one more topic that we want to drive home before sending you back into the real world: fixed versus fluid layouts. Fixed layouts are simple to explain. No matter how I resize my browser window, the width of the layout stays the same. Creating fixed layouts is easy and predictable. You simply use absolute measurements when prescribing column and element widths, things like pixels. But more and more professional web designers are moving toward fluid layouts, which use relative measurements like percentages and ems to determine widths and heights. Why, you astutely inquire? Well, mobile web browsing is becoming a staggeringly large portion of traffic on the web these days. Not only are mobile devices much smaller than your average desktop web browser, but the pixel dimensions and pixel densities also vary widely. There are also a staggering variance in laptop screen sizes out there. So the only way for a single website to optimize itself for any device is to become responsive to the environment on which it appears. Now this is where the term responsive web design comes from. Creating fluid width websites that maximize the space available to them is the first step toward creating responsive designs. We'll save the ins and outs of responsive design for a future video, but for now, trust us, this is a technique you'll want to focus on. Let's look at our Northeast Kingdom website, all typographically fancified since Jessica got a hold of it in our last video. Let's see what a little positioning and floating can do to turn this vertically oriented design into a fluid multi-column layout. Check out the last example link below to see the end result. Go ahead and resize your browser width and watch as the design adjusts to fill the screen appropriately. Remember, this is the first step toward a responsive design, so there are limits. If you shrink your browser below 800 pixels wide, then you're probably asking for trouble. But we'll solve for these edge cases and the mobile cases when we cover responsive design in the future. How did we get here? Well, let's start with the HTML Jessica left off with in the last video. Open the first example below in a new tab. This version has a fixed layout, 900 pixels wide, centered in the browser. Now open the second example, and you'll see I've done some very basic HTML tweaks that will help us create a layout with floated columns of content. I've surrounded the page titles, about paragraph, and main image for the site in a div with an ID of about. This will help us address CSS rules to this whole section of content. Just for fun, I added a little ornament to the title. A great place to find ornament HTML characters is at copypastecharacter.com. They've got an option to copy the HTML symbol code directly to your clipboard, so you can paste it right into your HTML. Super convenient. I've removed the photo corners. We won't need them in our new design, and I've swapped the old poached egg image for a new, larger one that will scale better, and I wrapped it in a div. That's it. Just a few key HTML tweaks. And that's as it should be, right? I mean, HTML is for marking up content, and CSS is where the style magic happens. Speaking of which, I've cleaned up the CSS in example 2 so that we're all set for moving forward. Open the third example and check out the CSS. We've only done two things. We've positioned the sections of our page using floats, as well as set the widths, padding, and margins using percentages and ems. Now look back at the fourth example. In step 4, we've just added some color and background image changes to finally bring it all together. The one big change is that we've added position absolute to the image wrapper and set its top position to 0 and width to 100% so that it fills the top of the page and scales the image to fit. Okay kids, let's recap. The total dimensions of an HTML element are the sum of its content, padding, border, and margin values. Every HTML element has these values, and they're always in that order, from inside to out. Vertical padding and margin only works if the element being styled is displayed as a block-level element. Inline elements don't want to hear it. Every element defaults to one or the other, but you can make any default block element into an inline element, and vice versa using the CSS display property. There's two main ways to position elements on a page, using positioning or floating. Positioning an element relatively moves it relative to its natural position in the document flow, but doesn't affect the content around it. Positioning an element absolutely removes it from the flow and positions it relative to the first parent element that is positioned relatively. If there aren't any parent elements relatively positioned, it will position itself relative to the browser window. This is great for things like side notes. Fixed positioning removes an element from the flow and fixes it to the frame of the browser. Great for stationary page controls. Floating is the best way to create multi-column layouts, but remember to clear after the last float, otherwise the parent element containing your floated elements will collapse in on itself. And lastly, fluid layouts resize content proportionally to the browser window by using percentage-based widths. This is great for optimizing your site for the wide variety of screen sizes and devices out there, and is the first step toward creating responsively designed websites. Well, that does it. You're now a layout champion. Join us next time as Jess takes us on another webtastic nerdgasmic adventure show. Later.